Okay, so basically we have discussed about pointer and function in last two lecture. Today we will discuss about the structure and union. Okay, now what we will cover in this, so structure in C, structure declaration, recursive defined structure, member access of structure, memory layout, bit fields, structure as a functions argument, and union. So structure in C. Now what is structure? So it's a aggregate in that they holds multiple data items at one time. Means before a structure, suppose we are talking about, let us store the value, we have options like a variable. Okay, now second, after sometimes we feel that suppose I have a multiple data with the same data type, I might go for the array. That is a we can say that a sequential collections of variable. Now we have a different types of data type, and we would like to club all of this together, and we would like to give one common name of them. Then we have a choice, that is a structure. So aggregate in that they holds multiple data items at one time, named members holds data items of a various types, like the notion of the class fields in a C and C++, but without the data hiding a features. Okay, so it is almost similar to the class in C++, but here we cannot hide the fields, means all the member of the structures are publicly accessible by their variable name. Now another, that is a scalar, in that C treats such a structure as a unit, as opposed to the array approach, appointed to a collection of members in a memory. Entire structure, not just a pointer to structure, may may be passed as a function's arguments assigned to a variable, etc. Interestingly, they cannot compare using a rational to inefficient. Basically, we cannot use a relational operator equal to compare two variable of a structure. Another point, that is a structure declaration. So basically, how can we define a structure? So here, combined variable and a type declaration. So struct is a keyword, right? Struct is a keyword. Then member list and variable list. Okay. Any one of the three portions can be omitted. So structure. Then here it's we can say that integer A, integer B. Okay, so integer A and B, these two are member of a structure with type integer. Another member of a structure, that is a integer, sorry, character star P, that is a pointer to character. So third member variable of a structure. X and Y, this is a variable list of a structure. So basically, if I would like to access the member of a structure, I need to go through variable X or Y. Variable X and Y declare with a variable as described. Integer members A, B and character pointer P, X and Y have the same types but differs from all others, even if there is another declaration. Structure integer A, B, character star P and Z. So Z has a different types from X and Y. So basically X, Y and Z, all of these three are individual variable of a structured data type. Fine. Now structured declaration. So in this case, basically we do not tag, right? We haven't used this tag. So now in the next definition, we are using the tag. Well, tag, we can say that a tag name S. So structure S, integer A, B, character star P, and omits the variable. So basically we haven't defined, or we haven't declared the variable of a structure right now. So no variables are declared, but there is now a type struct s that can be referred to later. Struct s, so this is the basically name of a structure, and z is a variable. So given an earlier declaration of a structure s, this declares the variable of that type. So type def, again we are using the type def keyword. Type def, this is the structure keyword, and this is the structured definition. So basically this is a structured definition, and we give the name of that structure using a type def, that is a s, right? So omit both tag and variables. This creates a simple type name s, more convenient than the structure s. Okay, so that is all about the declaration of a structure. Now another, that is a recursive defined structure. Obviously you can't have a structure that contains the intents of itself as a member. Such a data item would be infinitely large, but within the structure you can refer to structure of the same type via pointer, right? So struct tree node character star label struct tree node. So this is the member of a structure tree node. So itself a member, uh, or we define a recursively structured definition. So tree node and left child and right child. So basically left child and right child are a variable of this structure. Okay, and itself a member of tree node. When two structure refers to each other, one must be declared in incomplete complete prototype fashion, right? So here structure nested of a structure, like we have referred the nested of a loop, or if structure, nested if else, or like that. So we already referred those structure. Here nested of structure. So structure human, structure pet is itself a we can say that itself a variable of a structure, right? Structure pet. Now character name limit, character species name limit, then another variable of human. So recursive structure variable. So struct human star owner, and so this is a human, and this is pet, and this is a nested structure basically. And here variable of this pet, that is fido, and name of, see we are passing the first value, that is fido. So it will be set as a value of this name, and we can say that uh, canis lupus familiarities, this is the name of this species, right? And for human we pass we create one more variable, that is a name, and struct pet this. So same and fido will be passed. Now what is the point over here? When two structure refers to each other, because pet is refers to human and human will refers to pet, one must be declared in complete prototype fashion, right? So we can't initialize, basically we can't initialize the owner member at this point, since it hasn't been declared yet. If I pass fido over here, what happened with this? Because fido is depend upon this, and fido is also depend upon the owner, right? So it shows that basically fido is undeclared, and thus we cannot use fido to declare the variable of human. So basically, since it hasn't been declared yet, and that is why we cannot initialize the owner member at this point. Okay, how can we access the member access, or how can we access the member of the substructure? So we can go for like a direct access pointer, like suppose s is a variable of a structure, and dot m. So we can say that s dot m is the way to access the member of the structure. Subscript and dot operator have a same precedence and associate left to right, so we don't need two parentheses for the same dot pad of s 0 dot spaces. Indirect access. Why indirect access? Because suppose we are trying to access uh, this uh, pointer variable. In that case, indirect access is required. So S member access operator. This is member access operator. M, that is equivalent to star s dot m. Either we can go for this, right? Either we can go for this, right? Either we can go for this or we can use this one. Okay. uh, Difference a pointer to structure, uh, then return a member of that structure. Okay. Dot operator has a higher precedence than the indirect operator, so parentheses are needed in star s dot m. Otherwise what happen, s dot m, it will try to work with this s dot m, and whatever the data we get, it may try to fetch the value using star operator, right? So star will try to fetch the value located on this address, whatever the address we may fetch using s.m only. That will be like, suppose we are writing in this way s.m, then this may refer some address, suppose 1000, then 1000 may be, so star may be used to fetch the value from 1000 location. So that is why bracket is required if we are working with a dot operator. Star fido honor dot m and fido dot honors member access m, these two are same, this is same, fine. So dot evaluated first, access the honor member, star evaluated next, difference dereference pointer to the human. Dot and arrow have equal precedence and associated with left to right. Another, that is memory layout. Now how actually memory will be allocated to this structure? So here suppose I have structure named cost and having a two member, one is the amount of type integer, another is the currency type or currency type array of type character. So this particular things, this may holds two variable, sorry, two character, and this is one integer, right? Another structure, that is a struct part, character id 2 and struct cost of 2. So here we declare the variable struct cost, and cost is the variable of that, and integer number, we can say that integer number avail. Okay. Okay. Then layout of the structure part, that is here for the first structure, yes, for the part structure, layout of the part structure. So id, right, id, that is first integer, sorry, character with id, and two character 1 and 2, so 2 byte. Structure cost, so suppose we assume that there is a space between, or this memory will be used for the structure cost, then cost may have amount. Yes, as we already know that we are dealing with GCC, that is why it shows that 4 byte, 1 2 4 3 and 4 byte for amount for integer, right? Same for the currency type, so 2 character 2 byte. So this is for we can say that cost. Another, so cost second, and third is integer again, the number avail with 4 byte, fine. So here the system uses 4 byte alignment of the integer, so amount and the number avail must be aligned for 4 bytes listed for each structure. Okay. Now a better alternative form from a space perspective, because if I define the structure like that, cost and part, then 4 byte will be we can say that wasted. If I declare the structure like that, like integer amount, which already there, and character currency of type 2. So here character currency of type only character currency type, that is with a single character, right? And then after we declare the variable structure cost post and character id of 2 and number avail, then we will not lost this 2 byte over here. Now you might think that why we waste this 2 and this 2, total 4 byte over here. The reason behind that is here id. What is the id? That is a character. So we need to skip total basically for declaring the structure we need to start with the uh, full byte, or we can say that okay, uh, we need to skip at least a byte, full byte. We need to occupy the full byte, and then after we can use the memory location for storing another variable. So that is the reason behind that. Suppose we declare the structure like that, it will not uh, waste the memory. So hold the same data with a similar uh, memory structure. Another, so if you have a certain doubt regarding a memory layout, it will be cleared more clear with the help of a bit field. Now why bit field? Then I can say that, see, we know that integer, character and float, right? Integer may hold 4 byte, character may hold 1 byte, and float may hold or instead suppose let's go for turbo C, then integer may hold 2 byte and this is 4 byte, suppose, right? Now important thing is this is in terms of byte. Okay, now what happened with this? Suppose I would like to store uh, suppose I declare the variable integer and Zender. Now how many options available for the Zender? Then I might go for Zender equal to male or female, right? Female. These two options are there, right? Now how many bytes required to store male or female? Suppose I would like to store this in form of a character, then 6 characters required, one last for a null, so basically 7 characters required. For this one 4 characters, or sorry, 5 required including null. So maximum character size, that is a 7. So suppose I will go for character Zender with 7, one array, then it is easy to store Zender using a character, right? But what's my purpose? My purpose is I would like to identify the Zender only. So instead of this, suppose I am thinking that don't go for male and female, and instead let's go for M and F only. So now I can store it as a single character, right? Z. So G will hold either M or F. So I can easily identify that yes, it's a male or female. Still I am not satisfied, and I'm thinking that let's use the integer. So I might go for integer and G. Now again, if I use G equal to 0, that is a female, and G equal to 1, that is a male, then again it will fulfill my purpose. 1 means male, 0 means female. But still, what is the problem with integer? Integer may occupy 2 byte. So Instead of 2 bytes, suppose I would like to go for the character, it's reduce the size and 1 byte. Suppose I will go for the small integer, then again it will fulfill the purpose with 1 byte only. Still I am not satisfied with the memory occupied by the system, and I would like to reduce it more. And in that case I can say that uh, I will go for bit filled. So because ultimately predefined, we can say that predefined structure or predefined data type may be used to store the data value. So here instead of that we have another choice, that is a bit filled, and that allows us to work more smaller than the existing ones. So if a space is a serious concern, you can select the number of bits used for each member. So here structure character. See, this is not a data type now, this is a capital. So it's the name of a structure. So struct char unsigned ch is colon 7. Now please be remember, whenever we are talking about bit filled, it's always work with integer only. Okay, unsigned character 7 or font 6 or size 19, that shows that I would like to work with this different bit. Means suppose we are talking about integer and turbo C, it may holds 2 byte, means 16 bits, right? 2 byte, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, yes. And another byte, fine, total 2 byte and 16 bit, right? That is integer. Here for storing male or female, suppose I use a single bit, this one, and if I hold 0 in that, instead of a 16 bit or 2 byte, I can complete my work with the help of a single bit only. 0, either 0 or another choice is I can go for a 1, right? So that is possible. So that's the work over here. Okay, here we are doing layout possible machine. So here ch, how many bits are there? That is 1 2, right? This is 1 2 3 4 5 6 and 7. Now font 6, so 1 2 3 4 5 6, and this is 19, so 0, sorry, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. Now if we work in this way, this is layout possibilities. So either it may store ch font and size or size font and ch, that's up to the machine, that's not concerned to us. But the point is total, I can say that total how many bits used, that is 19 plus 6 plus 7, so 6 plus 7, that is 13, 13 plus 19, total is 20, sorry, 32. Okay, so 32 bits used. Now 32 divided by 8, exactly 4 byte. So no problem with that. But just imagine, instead of this 19 or instead of this 6 or instead of this 7, suppose we are using like suppose let's go for a 15. So what happened with this? So 4 byte, sorry, 4 bit will be less, and it is 28. In that case also it is 3 point something, but ultimately it may hold 4 byte, right? Just imagine if we are if we are storing this all of this 3 individually and with the type integer, it may hold 2 2 and 2 total 6 bytes. So instead of a 6 byte, we might go for a 4 byte only. So that's all about the space concern. Space is the important point over here. Getting this? So that all things are possible. Okay, bit field members must be integer. That is the required if we are looking for a memory concern, and if we are trying to store the value in a bit format, we should have a data type integer only. If we are not explicitly mentioned that it's integer and only unsigned, means by default the type of the data is integer. Not this will not work on the machine with a 16-bit integer, as this holds 19-bit. That is important point over here, as we are talking about 19 bits. Obviously the machine architecture should be with at least type 32-bit structure or 64. Ultimately 16-bit will not work for 19-bit storage. Okay, portability is an issue. Do any bit field size exceed the machine's integer size? Is there any pointer manipulation in your code that assume a particular layout? Bit fields are synthetic sugar for a more complex shifting and masking. To get a font value, mask of ch and size bits, then shift right by 19. This is what actually happen in the object code. Bit fields just make it look simpler at the source level. So these all the things are may possible, like because shifting, masking, if we are applying such complex structure, of course it may override the existing ones and change the value too, right? Then let's understand one more remaining point of structure as a functions argument. Okay, so here the next one, that is structure as a functions argument. Structure are a scalar, so they can be returned and passed as an argument, just like integer as, character as, struct big, change struct. So what is this? Struct big, this is the name of a function, right? Now it may accept the argument of a structure, that is a struct big, right? And s is a name of a variable of struct big. Also it may return the struct big variable. So call by value, of course there are two concepts of calling the function, that is a call by value and pass by value, sorry, call by reference. So here this is talk about call by value. Temporary copy of a structure is created, so whatever the value of this as, the copy of that is created, and that may referred by some another, so not referred, the copy of the value will be copied to another variable of a change structure variable. Passing a large structure is inefficient, involves a lot of copying. Of course, as if we have a big structure, it is suggestible that don't copy or don't use copy of structure, instead of use pass by or call by reference. Avoid by passing a pointer to structure instead. So here void again, nothing to be returned, and change structure, change struct is the function, then struct big star s. So avoid passing a pointer to structure instead. Avoid this one. Doesn't mean that we cannot use it. What if struct argument is read only, right? Safe approach, use const. So const this, so again it's a pointer to structure, but now it's a const, means we cannot change, right? We cannot change the value referred by this pointer, right? Pointer may not be incremented, decremented, or pointer location may not be changed. Otherwise what happen, once we refer the structure block with pointer s, and then after inside the function, inside this function, s will be s plus 1 or something, we may lose the pointer to this structure. That may possible, and that is the reason, right? That is the reason not to use pointer to structure or avoid to use that. So that is all about the structure. So main concern is we may have more than one member functions, right? More than one member function, and we may refer those functions with the help of a variable of a structure. Okay. Now next point of this, that is a union. It is almost the same as a structure. So like a structure, but every member copied the same region of the memory. Structure, member and add, added together, name and spaces and honor. Union members are XOR, added together. What does it mean? Suppose we define the same using a struct keyword. Memory location for float f, then integer I, then character pointer s will be separated or individual. Means if I store the value in f, I am able to store the value for I also, and the character s may point to any block of characters, right? Not integer, but just it may hold something. So any block of character, let's go for 104. Okay, so that's possible in case of a structure. But suppose we are going for a union with this same structure, same uh, members. In that case, first of all, how many bytes occupied by the float, that is a 4 bytes occupied by the integer, that is a 2. By default, pointer may occupied 4 byte, as it will refer the address. So here ultimately we may have 4 byte. Now it's not a bit, it's a byte, right? So now initially, suppose I am using, suppose this is the variable of this union, right? That is a x, and suppose I am using x dot f as seen in the case of a structure, and I store the value 4. So now how many bytes occupied by the float? That is this 4 byte. Means this block may holds 4. I mean this in the sense, don't consider this 4 individual. This block of variable f will be used and it may holds 4. Then after this statement, suppose I am using x dot I equal to 2, this 4 will be replaced, and now this block is referred as I, and 2 may be stored in the block. Means at a time we can work with any of these 3, not all of these 3. In case of a structure, we may deal with or we may work with any of the all of these 3 at a time. But in this case union, we may store the value of any of this variable at a time. So if we are dealing with f, we cannot work with I. If we are work with I, we cannot work with a s or f. If we are work with a s, we cannot work with a f or I. We cannot, the mean is we can, but after I, like after f, if we are working with I, the stored value of f will be loss. So either a float XOR, an integer XOR, and string, because character star s, that is a string. So we can go for any of these 3. Fine, that is a union. Now up to the programmer to determine how to interpret a union, which member to access. So basically programmer needs to understand, because the concern is we are trying to identify the particular things with the help of the structure or union, right? So if we are talking about union, we programmer need to understand that by what time which variable will which member will be used. So that is why union may be used to occupy the less memory, often used to conjunction with a type variable that indicate how to interpret the union value. Here the type is enum. We define enum over here, right? And enum, then type, that is the name of enum. These are the we can say that the constant name of enum, that is integer, float and string. Then struct, variable. Then enum is type, and type union, that is a value and value. So of course this is a structure. We can use individual variable with this type name and value at a time. We can hold any one of them, right? Storage. Size of union is the size of its largest member, as I told you, because 4 byte for a float, 4 byte for a pointer default, right? But as that was the string, it may holds more than that also, because whatever the size we are storing, that will be held by the pointer. Avoid union with varying member size. For the larger data types, consider using the pointer instead. Initialization. Union may only be initialized uh, to a value appropriate for the type of its first member. So fine, that's all. It's end of this structure and union today. I hope you understand this. Okay, and